Hello and welcome back to another Sunday edition of AC with Wasey. I'm Wasey with Brazos River Air Conditioning. This is the second video in a series on indoor air quality. Last week's video we went over different types of filters, both media type and electronic, as well as UV lights and different air cleaners that you can use in your home to purify the air that is in your home. Today we're going to be doing some air exchange and fresh air control, why it's important in a home, and how that affects what your air cleaner or filter is filtering. So we're going to get right into it. You'll notice I'm using some pictures from the web. This one, the first one that we'll start with, is from ecohome.net. This is basically because I haven't had time to go through and make PowerPoints and stuff, so we're still not new to this YouTube stuff. Hopefully we get better at it as we go, but for now we're going to be kind of using some pictures and stuff from other sources. So as you can see in this picture, every home is exerting pressure and then has pressure being exerted on it from the outside. So if you have, say, a dryer vent like we have here, if that dryer vent was not sealed around the penetration, not just the dryer vent itself and the duct and everything going back to it, but if around that penetration was not sealed, then you'll have air that in a negative pressure home is being pulled in a positive pressure home is being pushed out. You have this around all of your outlets, anywhere wires go out, anywhere plumbing vents go out, anywhere HVAC vents are going out, around windows, around doors. All of these places allow basically anywhere air can pass. So, and then from there, you also have pressure from the home that's being pushed out. This is your bathroom fans, your dryer vent fans, your kitchen vent fans. All of these are putting air to the outside and removing pressure from your home. So basically you have a constant exchange of air no matter how tight or loose your house is. There's obviously a lot of building techniques that are getting popular right now, such as spray foam, that are reducing the amount of air that will exchange. Which is a good thing in some aspects and kind of one of those trade-offs to where you have some negative aspects that you have to address in your HVAC design because of the different building techniques. Aside from the type of insulation, for instance, usually spray foam is the tightest. You'll have bibs in walls and bats in walls and different types that basically allow more or less air. But aside from that, you also have different types of framing. If you're framing and using sheathing, you'll have a tighter home than if you frame and just put metal or siding or whatever you're putting as your siding outside on. And then upgrading from the sheathing, there's a thing called the zip system, and it's sheathing with insulation that's made to make a tighter home, and then they have some tapes and caulks and sealants that you can use on it to seal it even farther. We're not going to get into that in depth, but if you're curious about it, as a builder, if I was a builder, I would be looking into it. It's a really cool system, really helps minimize any air exchange. Matt Risinger with the Build Show, you'll notice that I reference him quite a bit in my videos. I really love what Matt does on YouTube. That's actually kind of why I got started doing this. Is he puts a lot of information out there for people, and he's a good source of information. He brings on very notable people to explain things, but you can go to his videos and see some proper installation of the zip systems and how to seal up a house tight. So there basically, when you seal a house, there's a certain amount of air that your home will hold, right? And there's a thing called a blower door test that you can do that will tell you exactly how many times the air inside of your home is exchanged or changed out with fresh air from the outside. For a home efficiency standard, the lower this number, typically the better off you are efficiency wise on heating and cooling your home, because the air that's inside your home that you have conditioned or you have heated or you have dehumidified stays in your home, so you don't have to reheat, recool, dehumidify that air. Um, the the problem with that is there's another side to the coin, and the other side of that coin is that air is not ever being exchanged out, so the pollutants in your air in your home stay in your home, and this can be offset by doing a fresh air system that we'll get to in a minute. So as a starting point, as we go through this, if you notice that you have a lot of the symptoms that we'll go through for a positive pressure home or a negative pressure home, or just bad air exchange in general, we encourage you to find someone that does a blower door test. We don't currently offer them, but hopefully in the future we'll have that set up. But do a blower door test and see where your home is leaking, how much it's leaking, whether you're in a negative or positive pressure, all of that good stuff. And then you can start to address those problems from there, consulting us or another HVAC professional or whoever it may be. But anyway, so this drawing here is basically just showing you that air can be pulled in and pushed out in multiple different spots. So from there, you know that you want to ventilate, right? You want to get the dangerous gases out of your home. You want fresh air being brought into your home to replace that air that is moist or stale or has viruses or bacteria or whatever it may be in your home. The EPA estimates that the top 5 air quality problems, I'm going to use some notes here, but the top 5 air quality problems in the U.S. begin with indoor air. And these problems that they're looking at are ones that cause health problems either down the road or immediately, and affect our breathing day to day, as well as our immune systems and everything else. And basically what they're saying is the most important problems we have to fix in what we breathe begin indoors, in our homes, in our workspaces, and things like that. Aside from just recirculating the air and it being moist or stale or whatever, you have problems associated with moisture from between growing mold inside the home and having the mold spores circulate through your home. You can have rotting wood, sagging doors, cabinet doors that don't close anymore because the wood settles one way or another because you have too much moisture in your air. Past that, you can get organic compounds inside your home. These typically come from you have a very tight home to where air is not being exchanged out. Your home is not leaking air out, and you use a window cleaner, a stovetop cleaner. You go through and mop your floors. All of these chemicals that we use in our home to keep our home neat, or we got ants in our home, we want to spray ants, we want to defog it for whatever reason. In a spray foam home, all of this stuff is going to stay in the home. Your air exchange to the outside is very, very low. So if you don't have a ventilation system, this stuff just stays in there and you're breathing it day to day to day. Past that, there's other chemicals. Acetone's a big one that comes up. Acetone comes up a lot because different paint, if you're painting a room or you're removing paint, if you're painting your fingernails, if you're spraying your hair, All of these things will add acetone into a home. If your spray foam wasn't mixed properly and it's off-gassing, acetone will be released into your home. And at that point, you need to address the spray foam as well. But just as an example, that'll be added into your home. I have a customer that we're helping right now that has several long-term and immediate health problems because of a bad spray foam job that's off-gassing into her home. She's trying to get it removed out, but removing spray foam is extremely difficult, and we're trying to add some fresh air systems into her home to get some of these dangerous chemicals out of it, but it's a very difficult process. So just be aware that all of this stuff does relate to day-to-day problems that we run into, and you don't want to think that it'll happen to you, but it happens to people all the time that didn't think it would. So when we're building homes or we're remodeling homes or whatever, and we're making them tighter, we need to prepare for the worst case scenario and make sure that we're addressing this air exchange. Past all of those dangerous chemicals, you've got your normal dust particles. You've got your kid coming home from school with the flu virus. Weston was out with the flu this week, and so when he comes home and he's sitting in the home sick, that virus is being breathed into your home, and it sits there and circulates, and if your home is extremely tight, it just keeps circulating within the home, and your other kids or yourself or the one that just got over being sick can become sick again because that virus is just circulating. Same with bacteria and different stuff like that. The air cleaners and everything that we went through last week, they'll help with that, but they're really meant to complement a good fresh air system. So with that, there's different types of fresh air ventilation that you can do. Natural ventilation just refers to you opening doors, you opening windows, etc. And that's a good way to exchange air. Basically, think of your home and the outdoors as like a positive negative pressure, right? So if your home is closed up, nobody's opening any doors, windows, etc., it's like your car sitting in the parking lot with nobody getting in and out of it for a day. When you step into that car, you feel that stuffy air. It'll feel hot or cold, but it almost chokes you, and you roll down the window for a moment. You roll it back up. That brief moment of getting some air from the outside makes everything in the car more comfortable. That's basically what you're doing with windows and doors in your house when one's just been sitting there, and you just get that stale air feeling. Natural ventilation is good if you're doing a lot and you don't care about the dust and different things from the outside. If you live in an area where there's a lot of smog, or you're in an area where you've had, last spring here in Texas, we had quite a few large fires north of us, and they were quite a ways north of us, but the smoke and the ash was drifting through the air down here. And if you have something like that going on, maybe you don't want to be opening your windows and stuff and letting that into your house, or you don't want to let the dust and dirt and everything else in to accumulate in your house. So if you're not going to use that natural ventilation, then you need a way to bring this fresh air in, at least to kind of get rid of the stale air. So you can do what's called a positive pressure system. A positive pressure system is basically taking an outside air intake, and it is sucking air into your home and adding it in. Usually it's added into the return air part of your AC system, and it distributes through the home via that. Most of the time this is done with an electronic damper on a timer. It's a lot better option than a mechanical damper that's just wide open all the time anytime there's pressure, but it still leaves something to be desired, because It's just kind of pulling it in. It's not filtering it. It's not conditioning it. You're just, if it's 110 outside, you're getting 110 degree air. If it's 70% humidity outside your wall, you're pulling 70% humidity in. So while that air coming in is good, using this type of system uh, can be kind of annoying at times, because you're bringing in all these things that you're trying to keep out anyway. There's systems that are built to just provide this type of intake that do have filtering and do have conditioning. We don't see them very often. Typically, if you're doing only one way like this, it's either an electronic or mechanical damper. And then the vice versa of that would be if you have a home to where you only want to let air out. You don't want to bring stuff in, but you want to get rid of anything inside. Whether you realize it or not, if you don't have outside air intakes, you're probably working with a negative pressure system. You have your kitchen vent fans, your bathroom vent fans, and your attic vent fans. All of these are taking air and removing it and sending it outside. When they send it outside and there's no air being pulled in, it pulls your house into a negative pressure. By pulling it into a negative pressure, it's going to draw more in from the outside. Basically, it would be like having one room in a vacuum and having the other room blowing air at it. Even if you put something between it, any little gap it has, it's going to open up that much more and allow that much more through there. There's a lot of things that come with a negative pressured house that you wouldn't really think of, but they call it sick house syndrome. But basically, it sucks in all of the stuff through your walls and your attic and your insulation. All of that insulation on a 50-year-old house that's been sitting there in the walls untouched because you haven't redone your sheetrock, that have mold or mildew or whatever in there. That stuff is all polluting your air as it comes into your home. So a negative pressure house is not something that you really want, but I would say it's probably as common or more common than any other type of system, just because anytime you turn a bathroom fan on or a kitchen fan on or whatever, you're essentially making your indoors a little lower pressure while making the outdoors a little higher pressure. If your AC system is oversized and you've got 3 tons of air in what should be a 2.5 ton house, you're pulling in a bunch of air from the house and putting it back, and that air will be similar to one another. But that's if your house doesn't hold the amount of air that you're sucking into that system, it's going to cause it to go into negative pressure. And so basically, this type of home produces a whole lot of problem when you see condensation on your windows. You'll actually see this a lot on spray foam homes. If your house is built with no fresh air intake and you're not adding any pressure to the house, you're just taking it out of the house, or your unit's missized or whatever, it ends up condensating the inside of the windows a lot because air can't pass through anywhere. So there's a lot of heat exchange going on in your window, which creates causes water vapor to build up, and you end up with condensation down it. Your fireplaces, stoves, gas heaters, all of this stuff will have trouble kicking on in this type of home because there's not enough air for them to fire on. That's positive and negative pressure houses. So this picture here is what's called a balance system. You have air going out, you have air coming in. In this particular example, you can kind of follow these here, and it's showing the air coming in being put into the return air system. This here is basically introducing it into the return air system so that it goes out with the conditioned air and gets conditioned as it passes through your unit. And it's being pulled back in through some exhaust and put back out, and it pushes the stale moist air out. This is a really good setup. You see this machine that they have here. There's different types. There's ERVs, HRVs. Depending on your climate zone, these machines will differ a little bit. There's different styles of them, but ideally you want one that is going to condition the air slightly as it comes in to conserve some of the energy that you've already spent heating your air, cooling your air, drying your air out, and to kind of maintain that humidity level. So when you go to look at a system like this, ask your HVAC professional, depending on your climate, what type of system you'd put in. As you can see, this is using the HVAC system, the heating, cooling, to distribute the air. This is by far the most common. If I was building a spray foam house and wanting a really tight house, this is how I would want to do it. I would be wanting to bring fresh air in, and your HVAC professional should be doing a design that takes into account all of your building features, your siding, your roofing, your type of insulation, all of this, to know how much air needs to be brought in, as well as how much air you need to be taking out to kind of offset all of it. There's a few things not shown in here that you don't typically think of that that have a bearing on this. So you can see here the lady cooking and the steam rising up off, and she has a kitchen hood that's putting air out. So if this system down here is balanced and it's taking 100 CFM in, it's putting 100 CFM out. If she turns on that kitchen hood and it's taking 40 CFM and taking it out, or your bathroom fan is taking 40 CFM and putting it out, that air too has to be replaced at some point. So there's a couple of ways to do this. I've seen multiple styles. I think the one that I like the most, that I probably won't have any customers do, as it's a costly setup and I just don't operate in that market at the moment. But Matt Risinger from the Build Show, he set up a house, his own house, and he has a setup with an ERV type system, and he has basically a duct going to each room, and his kitchens, his bathrooms, the utility rooms, the places that are producing this humidity, these smells, all of these things that you want to remove from your home, he has a pipe going there that is removing them. He doesn't have bathroom fans. He basically, this system runs 24/7 at a very low speed. It's removing this air, so when you take a shower, you don't have to worry about turning on a fan. It's already being removed. And then it's reintroducing this air into the bedrooms and the living room and the family rooms. All of these areas are getting fresh air, while all of the areas that are creating humidity and stuff are taking it out. I thought that was really cool. I'd never heard of anyone doing that, but it's a very, very effective way of doing it, in my opinion. A couple of things that we're trying to do to kind of offset this problem of having your bathroom and kitchen fans and needing people to remember to turn them on and use them. That way that smell or that humidity or whatever doesn't stay in your house, while still making sure that your fresh air machine is bringing in air to offset them in case it was outside of the normal operation of it. You can basically wire a sensor into your kitchen hood to where when you turn your kitchen hood on, it says, hey, I need fresh air, and it brings fresh air in. I haven't ever seen it done with bathroom fans, just because of the way they operate. It would be harder to do. The one thing that I have seen with bathroom fans that we are starting to try to do on all of our custom homes is we're replacing, typically on a new build in our area, I don't know how it is in other areas, I guess, but On a new build, the electrician supply the bath fans a lot of the time and not your HVAC company. This is because they're wiring them in with their rough in, and it's a lot of the time it's easier for them to just throw them up and wire them in than worry about where we're placing them as HVAC professionals. I'm changing this on our custom homes that I've been doing, and I'm now trying to supply the bathroom fans, and the ones that we're using are a quieter, more efficient model, which is always nice for your homeowner. They don't want to hear the fan from the next room. They don't want to use a whole lot of power. But the ones that we're using, they're a Panasonic, but they have a humidity sensor and a motion sensor. So you don't have to worry about your kids remembering to turn the fan on in the bathroom when they're taking a shower. When they walk into the bathroom, it senses movement. It starts it at a really low speed. If your humidity level gets above whatever percentage you set it at, we set ours at 50. If your humidity level gets above 50, it speeds that fan up and it removes that humidity as quickly as possible. Humidity in every home is a problem. You don't want to build mold and all of this stuff, but in a spray foam or a tight construction home, it's a major problem because that water vapor cannot leave. Those mold spores, once they're produced, will not leave. The bacteria and stuff that build because of it won't go. So there's dehumidifiers and ways around humidity in these homes, and we do use dehumidifiers to help supplement our HVAC systems in different homes. But for the most part, if you can reduce that moisture with a good fresh air system, you will be much better off. So we suggest doing a balanced type system. You're bringing in fresh air, you're putting out all of the contaminated air. Your bathroom fans are set to come on without a switch to where they register humidity, and they're taking it out before it's a problem. If you wire so that when you turn on your kitchen fan, you bring in fresh air, that helps, because most kitchen fans will exert a lot more air than you would really think. So being able to bring that fresh air in when that kitchen fan kicks on is a really useful thing, and you'll be able to keep a lot tighter, cleaner home. You don't have to worry about opening your windows, opening your doors, or your house being in a positive or negative pressure and slamming the door by itself anytime you try to leave it open because you've got pressure pushing out or pressure swinging in. So basically that's our ventilation video. I probably am not the most eloquent talking about this, but I hope it gives you a general idea of how fresh air systems inside and out work, some of the different things that they allow you to take out of your home. I know when I did the spray foam certification classes, they preach it because of smells. Because if you have a bad smell in your home and you don't have a ventilation system, that smell will remain in your home forever. And they end up with a lot of complaints and lawsuits over smells and humidity and stuff. So in the spray foam classes, they really preach making sure that you have a correct ventilation system. The issue is that it gets pushed from the insulation contractors to the HVAC contractors, and if you don't have an HVAC contractor that has taken the time and studied this stuff or doesn't believe in the fresh air intake, it gets left off of a lot of new builds. So if you're doing a new build or a renovation and you're using spray foam, your insulation contractor should tell you to properly ventilate. But if they don't, make sure you ask your mechanical contractor to include it on his bid. This is one thing you don't want to leave off. At the very least, you want to be bringing in fresh air so that you have some air that is healthy to breathe. We suggest getting that stale air out. Again, viruses, bacteria, mold, smells, household cleaner gases, all of this stuff will stay in your home. Spray foam is a really great product. We're not down on it. Sometimes when we talk about adding all of this stuff, people think that we are telling them not to use spray foam, and that's not the case at all. If we had the choice between a loose house that you did not need to bring in air and put out air, or a tight house that we could control the amount of air that we're bringing in and the amount of air that we're taking out, we would control it every time, because when you're just letting air drift in and out of your house, it's catching on all the insulation in your walls, in your attic, in your sheetrock, on your boards. All of this stuff, as the air exchanges, is going to get part. You'll have different stuff stick to your walls, and it's still in your house because the air is being pushed through your walls and through your roof. Whereas if you build a tight home, like Matt Risinger says, build tight, build right. If you build a good, solid, tight home and you control the air coming in and out, you don't have to worry about this stuff lingering in the house and where it's catching at and all of this. You're addressing your humidity problems in the kitchen and in the bathrooms, where most of it is created as it's being created. You're addressing the stale air in the home with a controlled ventilation in, and hopefully using an ERV or an HRV to where you're conditioning that air as it moves through. And then you're exerting out all of the, not only the moisture, but all the chemical residues, the viruses, the bacteria, all of that. So don't take this as a spray foam is bad video. Take this as tight homes are good, but we need to properly install ventilation and keep the air in a tight home as pure as possible. So that's all I've got for today. Hopefully it's useful. Hopefully you enjoyed it. And thank you for stopping by. Send us all of your comments and all of that good stuff. We have Brazos River Air Conditioning on Facebook, the YouTube channel that you're viewing this on, brazosriverac.com, and then you can always call or text us at 817-864-1412. Thanks for stopping by, and we'll catch you next time.